So this is 2000, AB number 4, and yes, it is no calculator. I double checked. It's a rate and accumulation problem because we are looking at a rate, and oftentimes these problems include integrating the rate function to find total accumulation. We have a case where water is being pumped into a tank at a constant rate of 8 gallons per minute. So I'm just going to write that down. In at 8 gallons per minute. I don't know if I need that for part A, but water leaks out of the tank. So we can call, I don't know, let's call that function leak L of t. L of t is root t plus 1. It's leaking out for the first 120 minutes. At time 0, the tank contains 30 gallons of water. So at t equals 0, volume equals 30 gallons. Okay. Part A. How many gallons of water leak out of the tank from time 0 to 3? So part A is looking at the accumulation of the thing that is leaking. So we are going to build our accumulator function from time 0 to time 3 minutes of L of t. Or if we were to write this using the actual function, because we will need to, it would look like that. Now this is a function that's reasonably easy to do a U-substitution on to find the antiderivative. Some people have recognized this often enough that they can just jump to the antiderivative, but I'll show you the U-substitution so you can see this. We're going to let u be the function inside of the square root. So du is equal to dt. When we do that substitution, our integral becomes u to the 1/2 du, and our boundaries need to now change. When t is 0, u would be 0 plus 1, and when t is 3, u would be 3 plus 1 is 4. Now let's take the antiderivative using the power rule. The power rule would add 1 to the exponent and divide by the new exponent. That's the antiderivative being evaluated from 1 to 4. Okay. If you wanted to, you could have also substituted back to t plus 1 and run the boundary of 0 to 3. Different people, different approaches. I tend to favor the top one. If I stick 4 into this expression, I get that. And then if I stick 1 into the expression, I get 2 times 1 to the 3/2 over 3. Now, I would get the same answer down here because it is the same integral expression. This is numeric, and you can stop at this point. For the people who like to push it further and find the exact value, this winds up simplifying to a value of 14/3. The part A is worth 3 points. You get 1 point for putting the correct limits on your integral. So if you knew that you needed to integrate from 0 to 1. You get 1 point if you knew that you were integrating the leak function, and then you get 1 point if you were able to arrive at the answer in either a simplified or non-simplified form. Okay? This is really common for type 1 problems where you're going to integrate the rate function. If you have no idea what's being asked of the problem, just integrate the rate function and you might land yourself 2 or 3 points, even if you don't know what's being said. And double check to see if it's asking about units, and units is not requested in part A, so we're good to go. All right, moving on to part B. How many gallons of water in the tank are in the tank at time 3 minutes? Well, if we want to find out the volume at any given time, we have 8 gallons per minute flowing into the tank, and from that, water is leaking out from time 0 to time t of our leak function. And I'm changing the variable so that we can not have an overlapping t there. Well, they want to know what is the volume at time 3. Well, the volume at time 3 is going to be 8 times 3, subtract 0 to 3 of s plus 1. And I'm realizing I forgot one thing. The volume started with 30 gallons. So there's also the fact that we started with 30 gallons in the tank. Okay. So added to the system, removed from the system where the system started. So we need to simplify this expression. We get 24 minus 14 thirds plus 30. And that is a numeric answer. And you needn't simplify it any further. You could if you wanted to. If you did go through the process of finding a common denominator and adding this all up, you'd get 148 thirds gallons. Okay. So again, I'll repeat what this is. We have water being added to the system, water being removed from the system, and the water that I start with in the system. This is worth 1 point. You have the right answer. Okay. Which means there are some people who would have evaluated this without even setting up the calculus portion of it, which is completely understandable since you did part A already, which was the calculus. On to part C. Write an expression, A of t, for the total number of gallons in the water of the tank at time t. Oh, we actually did that in part B. The amount in the tank, which I called volume, but the amount in the tank is the amount into the system for t minutes, subtract the amount out of the system for t minutes, plus the total already in the system at time 0. Okay. Now, if you were to view the key online, they wrote it in a slightly different order, but it's the same concept. Or another way they wrote it on the key online was they said the amount that I started with plus the amount that I add to the system, which is going to be 8 per minute, take away the leaking amount per minute. And they use the variable x instead of s, but it's the same thing. All three of these are suitable. If you were to take the antiderivative of this, you would start to arrive towards one of these ones up here, or at least a little bit. So this one is worth 2 points. One if you included the starting amount and the amount into the system, and 1 if you included the amount being removed from the system. Okay. So because of our work in part B, part C did itself. All right, moving on to part D. At what time does water reach a maximum? We have an equation that measures the amount of water in the tank. So if we want to maximize A of t, we have to find where A prime of t equals 0. So we need to take the derivative of A of t. Derivative of 8t is 8. The derivative of the integral is the integrand at the top times the derivative of the top minus the integrand at the bottom times the derivative of the bottom. And the derivative of a constant is 0. So we need to set A prime of t equaling 0. Solving this using our mad algebra skills, we square both sides and subtract 1. And we have one critical value, which probably means that's the maximum. But we really ought to check to make sure that that is a maximum. A prime of t is greater than 0 on the interval 0 to 63. I did a test point, like I stuck 1 into A prime of t, and I got a positive answer. A prime of t is less than 0 on 63 to 120. I stuck the number, I don't know, 60, let's go with 80. I stuck the number 80 into this expression. and I got a negative answer. Therefore, what's going on with A of t is increasing, and then A of t is decreasing. So we know we have that condition where our function is going to a maximum. Therefore, a local max exists at t equals 63 minutes. And they just ask the time, so we don't have to figure out what is the value of the amount. Okay? This is worth 3 points. The first point comes from setting a prime of t equal to 0. Okay? Even if you had the wrong a of t function, if you showed a prime equaling 0, I believe they would give you the point. Okay? Likewise, if you had the wrong a of t, but you successfully did the algebra of actually solving that, I believe they would give you the point. I know I would in my room at least. And then finally, the justification comes from what I'm stating here, where we're increasing until 63 and then decreasing afterwards. Therefore, a local max exists. So that's the first derivative test for local extrema that we employed there. Thanks for watching. Comment, like, subscribe, smash that like button, hit the bell for notifications. Jake's got a better one?
Yeah.
Jake?
Like, comment, and subscribe.
Boo!